In this problem, we are asked to find the equivalent resistance for the circuit and the current through each resistance. So if we look at the 6 ohm and 3 ohm resistors, those are what is called in parallel. In parallel meaning that at some point the current as it goes through the circuit will have a choice of going one of two ways, either in the 6 or in the 3. The equivalent resistance, let's call it 1 over R, 3/6 for 3 ohm and 6 ohm, is going to be 1 over the 3 ohms plus 1 over the 6 ohms. And if you do some algebra, you find out that R 3/6 is going to be the 6 ohm times the 3 ohm over the 6 ohm plus the 3 ohm, which gives you a 2 ohm resistance. And now your circuit becomes something like this. So now we have the 4 ohm here, we have the 2 ohm here, which is the equivalent resistance for the other two. It's still 18 volts. It still has negligible internal resistance. And now you notice that R2 4 ohm and 2 ohm in this circuit are in series, which means that the equivalent resistance is their sum. So this gives us 6 ohms. And now my circuit becomes, as we see, there's only one resistance, the equivalent resistance for all of them, which is equal to the, or equivalent to the earlier circuit that was given to us. And because now we have the equivalent resistance of the voltage source, we can use Ohm's law, which says that V equals IR. So I in this circuit is going to be V over R, which is 18 volts divided by 6 ohms, or 3 amps. So now we know that the current through here is I, which is 3 amps. And now we start going back in the process and say, okay, well, here's the circuit that we had before we combined the last two. So this is 4 ohms, this is 2 ohms. And because they're in series, implies that the current through the 4 ohm would equal the current in the 2 ohm. And in this case it would be 3. So there's no extra work for that. And now if we take one extra step backwards, this came from the 2 circuits that 2 resistance that we see here. And in parallel, the voltage across the 3 ohm has to equal the voltage across across the 6 ohm resistor. So in series, the currents are the same. In parallel, the voltages are the same for the resistors that are involved. So the voltage across the 2 ohm is going to equal the same as the voltage across the 3 ohm, which is the same as the voltage across the 6 ohm resistance, and that's going to be the 2 ohm resistor times the current of 3 amps, which is 6 volts. And now if I want to find the current through the 6 ohm resistance, that's going to be the voltage across the 6 ohm resistor divided by 6 ohms, which is the resistance there. And that would give me 6 volts divided by 6 ohms, which is 1 amp. And the current through the 3 ohm resistor is going to be 6 volts divided by 3 ohms, which is 2 amps. So if we go back to our original circuit, we know that we have a 3 amp current going through here. We have a 1 amp going through here. And we have a 2 amp going through here. And that would solve